All right, normal distribution part 2, Z-scores and using the normal distribution table. I'm going to show you a couple of different ways to get areas under the normal curve. We'll use a normal distribution table just because that's kind of the textbook way, but then I'll show you later how to do this in R and not have to mess around with that stuff. Oops. All right, so Z-scores. If you Google Z-scores, you'll probably find multiple formulas for them. I want to highlight both of them, and even though we're only using one of them at this point. So for a single score and for a sample, which we'll talk about in a section later on. For a single score, the formula is simply the difference between the individual score and the mean divided by the standard deviation. So if the individual score is the same as the mean, the Z-score would be 0. If it's above the mean, the Z-score would be positive. If it's below the mean, the Z-score would be negative. And for a sample, I just want to throw this formula up in case you see it. We're not using this formula at this point. This is for when we have a sample and we're talking about mean values compared to some value in a population. And those, don't worry about that right now. Those things will make more sense as we get deeper in the semester. All right, so back to grading. Where did those percentages that I threw up come from? How did I get to about 7% for a Z-score of 1.5 for the A? Well, let's take a look at what Z-score of 1.5 means. So we're going to be asking what proportion of scores would we expect to have Z of 1.5 or higher. There's multiple approaches available. You can use what's called a Z table or a table of normal distribution probabilities. That's pretty old school. I'll show you anyway. You can use internet resources. You can just Google, Z-scores, and you'll come up with numerous calculators for doing this. We can also do it using some pretty simple functions in R. Here's what a normal distribution table might look like. It'd have a bunch of columns, but the main thing to attend to is column A, which is where the Z-scores are, and I've highlighted where our Z of 1.5 is. And then it gives you 2 different pieces. Some of them give you 3 different pieces. In column B, it's the area between the mean and Z, and column C is the area beyond Z. And one thing you'll see for all of these is that those 2 columns will always add up to 0.5, to half of the distribution. You'll generally see a table like this just represent positive values because it's the same exact thing for the negative values. This distribution is completely symmetrical. What you see on one side has a mirror image on the other side. So applying this, we're interested in what is noted here as the area beyond Z. That's going to be a Z of 1.5 and higher. And if we look at the table, we get about 0.0668. So that's where that 7% value came from that I threw out. The value in column B, that tells us what proportion of scores fall between our mean and Z, so about 43%. And then if we add 0.5 to that, that tells us the entire area that falls below Z, 0.9322. Yeah, you'll notice 0.9322 plus, I'm sorry, that should be 9332. Let me fix that for you. 9332 falls below Z. That's just 0.5 plus the mean and Z area. So another way to represent that is it's 1 minus our Z of 1.5 and above area of 0.0668. All right, how about a C grade? If we look at the C grade, useful here to get a representation that's graphical. So I made a graph here that's showing us what we're looking at. We've got negative 0.55 and 0.55. So we're going to need to use a slightly different strategy here to get this proportion. And again, negative 0.5 is just 65 minus 70 divided by 10. Positive 0.5, 75 minus 70 divided by 10. So we can actually use those pieces that say the area between the mean and Z, and it'll be the same for 0.5 as it is for negative 0.5. That area is 0.1915. So we've got that on the left-hand side, and we've got it on the right-hand side. So we have those individual pieces. We just need to add up those 2 pieces, and then that's going to tell us what proportion is going to be between those scores that give us a C, and it's 0.383, corresponding to that 38% value that I showed. That's it for this part of the section. Next, we'll move on, on to how to do this using R.